For ways we could divide here on number 32. We could long division if you're into long division. Or we could synthetically divide if you're into synthetic division. Whoever's going to do this problem here with me, you get to decide. Here you go, 19. What way you want to do it? Synthetically divide? All right, so if we're going to synthetically divide, and I have x minus 2 here, what's got to go in here? 2. All right, positive 2. And then what do you remember, Owen, what do I have to write across here? The numbers out in front, the coefficient. So what am I going to write here, Owen? 3, 7, and negative 20. Because as you guys have found out the last couple weeks we've been reviewing, there's a lot of traps in this test. Please make sure that the exponents go down in decreasing order. Because if you're missing an exponent, you still have to fill in a what here? A 0. Okay? So if it went something like this, 3x cubed plus 7x minus 20, I would have to do 3, 0, 7, and negative 20. Okay, so please watch out for that. All right, I would not be shocked at all if they did that. All right, Owen, here we go. Let's go back to you. First thing I do, bring down the 3. Okay, bring down the 3. What's your next procedure here? Because we haven't reviewed synthetic at all yet. Multiply now. 3 times 2 gives you that 6 right there. Positive 6 and a positive 7. 13. 13 times that positive 2. 26. Negative 20, positive 26. 6. Okay, the last number is usually your what? Remainder. All right, so how do I write this now? Well, you started with 3x squared, so it's probably not going to be 3x squared again. No, it'll be 3. 1 less on the exponent. 3x plus 13. And now this is your remainder. They tell you how to write it, but even if they don't, we should still write it like this. Plus 6 over what you were dividing by, x minus 2. All right. Questions, comments? Or you could if you did long division, still should work out. All right. Any questions on that? Oh, and nice job, kid. All right, 31. Is it independent or not? Okay, is it independent or not? Way you test. First of all, what are the 2 things I'm testing are independent or not? What are the 2 things? 6? Who's got 6 here? Who's going to roll with me with this one? 6? No 6? Okay, here we go. What are the 2 things I'm comparing? Male versus reality series. Male versus reality series. So the first thing I need to set up, and I don't care the order, what you put first, male or reality, it doesn't matter, is one given the other. So male given reality series. Or reality series given male, doesn't matter. Equals the probability, now it does matter, whatever you chose first. So this probability should be equal to male if they're independent. That's got to be true. If you did reality series first, this would be reality series. Okay. It's about the 3rd or 4th time we're doing this right now. The conditional probability. Okay, here we go, boss. What should be going on top of any given or conditional probability here? It's a formula. That's in your formulas you need to know, but not on the reference sheet. What should be going on the top of any given probability? Do you have that sheet on you? Because I'd love for you to get it out so you can remember it if this occurs in 2 weeks. I had you copy it down. It's not one that was typed in. It was one that we copied down. You probably have A given B somewhere in there. And I need to know what's on top here. Which means what? Okay, so here, I'm asking you to go to your table and find out how many are male. I am this whole problem. No. What did you just tell me the formula is? What goes on top? Okay, so I'm looking for male and reality series on top. So if you go to your table, male and reality series, what are we looking at? 70. Keep that formula handy. What should I be putting on the bottom? Where'd you get that from? Oh, no. Look at your formula. And what's RB here? Okay, so now what's the total reality series? Okay, here we go. The both over the given, everyone. Both over the given. All right, let's go here. Now I need you to use the table. What's the probability of male? How many males are here now? $230 out of. Okay, now I have to determine, are these two fractions equal to each other? There you go. Yep, go ahead. Right underneath your binder there. You already got it out. There you go. That would be a no, meaning they are not independent. Everyone good on testing for independence? And again, finding a given probability. Any issues? Yep, go ahead. Yep, they do a different way. That still works, yep. If you found in the answer booklet, you do probability of male, probability of reality series, and then see when you multiply them, is it equal to probability of male and reality? Yeah, that's another way to do it. Instead of trying to show you guys two ways, I'd just rather focus on one, all right, so you don't get confused. But yes, Mark, you can do that. Whoo, yeah, here we go. Little trig graphs here. Let's do this. Who's got 8? 8. All right, it's done. What type of function are we looking for first, Brendan? Because I'm going to eliminate 2 of these. Cosine. And you know cosine starts somewhere other than? Well, let me put it this way. Where's sine start? Where? 0. So which 2 do you want to eliminate here that I know definitely are cosine graphs? Okay. 2 and 4. Everyone all right? While we're eliminating 2 and 4, those are sine graphs. They start at 0. 50-50 shot now. Biggest difference here, let's see. This is pi over 3. This is 2 pi. What's the period here, Brendan? 2 pi over 3. What's the word period mean? How long it takes? Do 1. How long it takes? So they're telling me it takes 2 pi over 3 to make 1 cosine curve. Let's look at these choices right now. Ready? There's 1 curve, right? What's that value here? But how long does it take to make 1 full curve? Isn't 2 pi over 3 bigger than pi over 3? So everyone see, it couldn't be this one because it's taking 2 pi over 3 to make a full curve. And this is already making a curve less than pi over 3. And we know 2 pi over 3 would be, take a look, 2 pi over 3 would be, oh, it's even over here. There you go, even better. How long? It's making 3 curves instead of 1. We all good there? I don't need to go into finding the b value or the equation here, right? So that's how I know it's going to be choice 3. Are we all right there? Period is how long it takes to make 1 full curve. Well, 1 full curve, geez, I'm making 3 full curves at 2 pi over 3. All right. All right. Oh, average rate of change problem. There's a shocker. 4 people ready to go, just like yesterday. 10 to 60. 19 to 69. And 36 to 72. And 60 to 73. Okay, I'm not saying a word. I want to know what over what here. And then you can calculate it if you haven't calculated it already. All right, so for 10 to 60, let's hear it. Not saying a word anymore. 8 again. Go ahead, Brendan. What are you? Actually, no, I'm going to pick somebody new. I don't want new. 4. 4. Okay, here we go. For 10 to 60, what should I be writing to find its average rate of change? Yep. Yep. Over. About how much there? Austin, when you get a chance, about how much? Okay, thank you. Good job. 28.4. Okay, next one. Let's go. Next one. 18. No 18? Go ahead, Shannon, go. 19 to 69. Over. And about how much? Yep. You guys are doing a nice job. Here you go, number 3. What am I plugging in? Let's go. 6. Okay. 3,000, what was it? Okay, minus. All over. Okay, when you get that calculation, let me know. Okay, so 1 and 2 are obviously out. All right, so let's check 4 finally. Here we go. 9. And what are we looking at for this one? Final answer then? Knowing all these rate of changes, number 22, final answer? Okay. Okay, that's fine with me. 4, oh, already had it. Let's go. 16, final answer? No 16 either? All right. There we go. Rate of change, rate of change. A lot of rate of changes going on. All right, this was your last one that you had. I'll do this one. This one should be a simple one, I hope. All right. G of x, some random function, I divided by x plus 4, so the remainder is 0. What do I know about x plus 4 then? Although I don't want any advanced knowledge here. X plus 4 is a, what do we call it? Well, it's not a solution. A factor. X plus 4 is a factor. It goes into g of x because the remainder is 0. Okay, now, because it's a factor, now go advanced on me. What's a solution then? X equals negative 4 is a solution. Meaning, when I plug negative 4 into the polynomial, what should I get out? 0. Yep. When I plug negative 4 in, I should get out 0. All right. Questions? Anything there? So that's what I had you do last night. I only got a couple problems for you to do today, and then you're going to go on your own, just like yesterday. All right, here we go. 34. Let's roll. 34. I want to do a big dog one and a couple multiple choice. And have out your actual formula sheet. What's up, Hannah? 8. Did I forget one? I did. I'll make sure to remind me before I let you go. Okay. You are correct. Have your actual formula sheet out for this one. Okay, here we go. Go ahead, read through the Elena and her plan to run the half marathon. This is something I wanted to definitely do today because we haven't reviewed sequences yet. Here's Jillian's plan in dots. Here's Josh's plan. She's going to follow one of them. Which one's arithmetic? Okay, which plan is arithmetic and how do you know? All right, difference again. What's arithmetic again? What type of sequence is arithmetic? If they add the same number. Geometric is if they multiply the same number. So which plan up here am I adding, because it's arithmetic, adding the same number every time? Okay, so which one up here does it look like I'm adding it? Here we go. Oh, nobody. Who had 16 before? Oh, there we go, 9. Never mind. Which one am I adding every time? Which one? Jillian's plan. Yes? Jillian's plan, yeah. Why Jillian's? Because what are you going up by every time? Every week you're going up by what? 1, yeah. Because adding 1 every week. Okay, next up. Write a recursive definition to represent the number of miles you picked. So for Jillian's plan, we want to write a recursive. I went over this once and only once. You need 2 things for a recursive definition. Anybody remember anything here? I'm not going to call a number on this one. The 2 things you need to write a recursive formula. You need the first term. You need A1, which would be what in this case? First term, week 1. Well, she didn't run 1 mile on week 1. According to the graph, how many miles? So A1 is 10. And you also need to tell me what you do to the previous term to get to the next term. So to get to a term, anybody, how do we write the previous term? N minus 1, yep. So what do I do to a previous term to get to the next one? Read your graph, write out a couple numbers if you need to. What am I doing to the previous term to get to the next one here? Here we go, 6. What am I doing to the previous term to get to the next one? I'm adding 1. So to the previous term, make sure it's out there plus 1. Don't make it as part of the n minus 1. All right? Those are the 2 things you need to write a recursive formula. First term, and then what are you doing in the previous term? All right, keep reading here. She's going to run a full 26. Week 1 now will start at 13. So week 1 will be at 13. She's going to follow the same pattern. So what's next week then if she follows the same pattern as the original plan? Okay, keep going. I know this is elementary-ish, but keep going. What's the next week then? 15, 16, and so on, right? All right. It's going to continue for 14 weeks. Great. Write a explicit formula. That's why you have your formula sheet out. The explicit formula is on your formula sheet. Everyone see where it says arithmetic sequence? Everyone sees where it says arithmetic sequence? Okay, what's that formula? A sub n equals A1 plus n minus 1 times D. Our old buddy there. Yep. You're going to try to plug in everything but for n. Okay, everything but for n. All right. What's this represent? First term. All right. Let's hear from some people. What's my first term? 12. What's my first term here? No 12? 12? Okay. How about 3? 13 plus, when it asked you to write an explicit formula, n stays n. Anybody remember what that was called? Common difference, which is what? Not in this case, but just in general. Your common difference is what you're adding, what you're going by. And what am I going by according to this one? 5, 1. Could somebody go back to the directions for me? Why this is not going to work? Gianna? Simplest form, meaning keep going. Distribute that 1. Add the 13 where you can. Okay? Simplest form. What happens when you distribute the 1? N minus 1. Anything else you want to combine? Okay, so A sub n is going to be equal to 12 plus n or n plus 12. Either one's going to be acceptable. All right. Explicit formula on the formula sheet. Recursive. Need to know something about the previous term. Whew. Ask away. Anything? All right, I think I have one multiple choice left. And then you got the rest. Yep, 27. And you will need your formulas not on the formula sheet packet, on this one. I believe I typed this one in. Cosecant. Cosecant. Is the reciprocal of sine. It's on there, right? We'll look at your sheet. I believe I put it on right bottom left-hand corner. Everyone see cosecant? Reciprocal of sine. 1 over sine. Okay. We're trying to show why this is going to be equal to 1 over y. Okay. All right, everyone all right on the first part? Cosecant's 1 over sine. What type of circle are we using? All right, that's the other key to this problem, is the unit circle. It has been months, but do you remember any point on the unit circle, x, y? Do you remember what the x represented? Or maybe what the y represented on the unit circle? It's okay, that's why we're going to review. X was the cosine of the angle, and y was the sine of the angle, yep. Only on the unit circle. The cosine is the x-coordinate, the sine is the y-coordinate. All right, so keep going for me here. We're on the unit circle. What coordinate represents sine? There you go. And some people are like, that's all we had to do? What part is this in? What part is this problem in? Part 2, how many points is it worth? 2. So it shouldn't be much work. All right, that's it. You just got to show, you know what cosecant's equal to, and the fact that you're on the unit circle, that the sine is always equal to the y-coordinate. All right, that's all you needed to show. Which number, Hannah? 18? Yeah. 18, yep. Go to 18. I had you guys do 18 last night. I just forgot. This one's a quick one anyway. Just do we know the formula or not? Okay, here you go. Which interval reflects 95% of the critical reading scores? What do we call that? The interval, again, that represents 95%. We had an actual name for it. Confidence interval. And if you remember, confidence interval is equal to mean plus or minus my margin of error. Okay, but you need to know how to find margin of error, which is plus or minus 2, not plus, times your standard deviation. What's my standard deviation here? 115. So it ends up being plus or minus 230. Okay. So going back to my confidence interval, what was the mean? 496 plus or minus the margin of error I found, which was 230. There it is. That was just knowing the formulas, right? You all right, Hannah? I'm good on that one? You sure? Clear it up? Perfect. Oh, and if I don't know, I know some people asked this yesterday of me. I don't know if it was here or sixth period, but modal score, that's the mode. That's just a fancy way of saying 430 occurred the most. That was it. And of course, they had to throw that in there just to see if you would have taken the bait or not. So, all right, let's go. Let's grind away. Let's grind away. You can start with 1 through 5 if you want. You can start with 36 if you want. I'll be coming around helping you guys out. Let's grind away, work with each other. Move around if you want to work with other people that aren't sitting next to you, that's fine.